Hey, more transformations today, and we're actually going to be starting our last type of transformation. So we've covered all the isometries. Those are ones that produce congruent figures, translations, reflections, and rotations. Those are same shape, same size. Today we're going to cover the one non-isometry, which is dilations, and that creates a similar figure. So it'll be a same size, or same shape, it'll be the same shape, but the size will be proportional. So imagine just like taking a shape and stretching or shrinking using your scissors tool. A dilation basically looks like this. My pen is off. Okay, here we go. So if I have this heart and I wanted to do a dilation on it, I would stretch it out or I would shrink it really tiny, but the size is proportional, but it's not the exact same size. The rule for dilations, which I'm going to be going over in the video, is like this. You basically are multiplying the x and y coordinates by the same number, and that number is called the scale factor. And that's something that we're going to be talking about in the video today. I'm going to be showing you guys a selection of problems from here. Some of them may or may not be the ones that you're assigned to do. So make sure you complete the rest of the assignment that I didn't show in the video. So the first row, state whether a dilation with the given scale factor is a reduction or an enlargement. So those are our two choices, reduction or enlargement. So basically a reduction, you probably figured this out, but that's when you're shrinking the image, and an enlargement is when you're stretching the image. So these are 4 different examples of numbers that you might multiply the x and the y coordinate by, and they're called the scale factor. They use k sometimes for scale factor. So like for number 1, for example, if you multiply coordinates by 3, would that stretch the image or would that shrink the image? That's basically what they're getting at. Go ahead and complete problems 1 through 4. For each one, make a guess if you think it's a reduction or an enlargement. Pause the video for more time. Okay, so hopefully you've had enough time. Basically, the idea here is that if it's a number that's greater than 1, it enlarges it. So 1 and 3 would enlarge the image, and 2 and 4 would reduce the image. If you multiply something by a number greater than 1, you get a bigger number. If you multiply something by a number less than 1, you get a smaller number. So it follows the other math rules that we've learned as well. Section 5 through 8, they basically want the same thing. So determine whether the dilation is a reduction or enlargement, then find its scale factor. So what they're saying is they're going from figure A to figure B. And that's important because if you look at it backwards, you're going to get a backwards answer. So when you go from A to B, is it a reduction or an enlargement? Why don't we start from with that part? In the first line for each of these 4 problems, can you write reduction or enlargement? Pause the video, do 5 through 8. All right, hopefully you have enough time. In problem 5, A is bigger than B. So they've taken A and they've shrunk it. That means that is a reduction for number 5. Number 6, A to B, it's getting bigger. So that's an enlargement. On number 7, A to B is getting smaller, so that's a reduction. And on number 8, A to B is getting bigger, so that's an enlargement. The second part of this section is find the scale factor. So basically, they gave us the scale factor in problems 1 through 4, and I'm going to show you how to find the scale factor in problems 5 through 8. So the scale factor in an enlargement problem or a reduction problem, doesn't matter, is basically what we would multiply the first set of coordinates by to get the second set of coordinates. And there's many different ways you could find it. But basically we want to find a corresponding point. So I'm going to use these. And just to keep things simple, I'm going to call it some random letter. I'll do G and G prime because we're going from A to B. G is a random letter I made up. So G has coordinates 0, 3, and G prime has coordinates 0, 1. So basically the question is, what did I multiply the coordinates by in G to get the coordinates in 1? Or in G prime, I'm sorry, not 1. So you basically divide it in the opposite order then. So 0 is not going to help me, but 1 and 3 will help me. So the arrow's pointing at 1. I could do 1 divided by 3, and that's the answer, 1/3. So I multiplied G by 1/3, and that gave me G prime. We can test it out. Why don't I just show you one more point. So here we'll go with F and F prime. F looks to be at 1, 2, 3, so -3, -3, and F prime looks to be at -1, -1. So is it true that if I multiply F, each number, -3 by 1/3, and the other -3 by 1/3, do I get the new numbers? And yeah, I do. So the scale factor is 1/3. All right, so it doesn't matter what point you pick. You should get the same answer either way. Pick a point that is matched up on a line and it looks easy. If you guys could please pause the video and see if you could find K, the scale factor, for 6, 7, and 8, that'd be great. Unpause when you're ready to go over it. Okay, so for problem 6, doesn't matter what point I pick. I think I'll pick this point. So you just want to pick points that are corresponding with each other. I'll call it Q and Q prime. So Q is at 2, 0. And I actually see that 1 is way out here, but I don't want to work with fractions. So I'm just going to rename it to make it 2, 0. It doesn't matter. You can do that as long as you're consistent with both. So if I rename it to be 1, 2, 3, 4, 5, 6, 7, that's fine. Because it's all ratio, it's all proportion, so it doesn't matter. And Q prime is at 5, 0. If I had not renamed it and I had used like 1/2 and 1 1/4, I'd end up getting the same answer. So it doesn't matter. So question is, what do I multiply Q by to get to Q prime? And I have to divide it backwards to figure that out. So it's going to be 5/2. If I multiply 2 times 5/2, I get 5. So to figure that out, I do 5 divided by 2. Whatever the arrow points to divided by the other one. So the scale factor is 5/2. If I take any coordinate on this picture and multiply it by 5/2 or 2.5, I will get the coordinate that goes with B. So that makes sense. In problem 5, my scale factor was less than 1 because it was a reduction. In 6, my scale factor was greater than 1 because it's an enlargement. Okay, 7 and 8. All right, I'm going to try to pick a random point that I don't think any of you guys picked, just so I could show you that it works no matter what. I'll pick this, and I'll do Z and Z prime. It's a lot of pressure to pick a fresh letter live on a video. So Z looks to be at -6, 3, -6, -3. And Z prime looks to be at -2, -1. So there has to be some number that will give me the relationship that's the same for both X and Y coordinates. So I can either do -1 divided by -3, or I could do -2 divided by -6, and I should get the same answer. Whatever the arrow points to, divided by the other one. So either way, I end up getting positive 1/3. When you divide two negative numbers, you get a positive number. So the scale factor there is 1/3. And you may have picked a different point and gotten the same number. Lastly, 8. So it looks like all my points for A are in between. So I'm going to have to use some estimating. And again, I'm not going to worry about it being 6. I'm just going to rename it to 1, 2, 3. 1, 2, 3. I'm allowed to do this because I'm talking about ratios here. So I'll get the same answer if I thought about it as 6 or if I think about it as 3. It doesn't matter. So I'll use this point and this point. I'll call it M and M prime. M looks to be at 1.5, 1.5. Why did I write fifth? I do that a lot because I think about it as like 0.5 in my head. All right, and then M prime is at 2, 2. So how do I get from one to the other? This one will require a little bit of scratch work, or you could type it into your calculator. But 2 divided by 1.5, 2 over 1 divided by 3 halves. Leave it, change it, reciprocate it. And I end up getting 4/3 or 1 1/3. So if I take all my values from A and multiply them to get all the values from B, the number I'd have to multiply them by is 1 1/3. And it's greater than 1, which makes sense that it's an enlargement. If I didn't rename the axis and I'd kept it with the original 6, I'm going to be getting the exact same answer. So if I had said that M was at, so this would be then 2, 4, 6, 2, 4, 6. So M would be at 3, 3, and M prime would be at 4, 4. Actually, might have been easier to do it this way. They're whole numbers. They showed me. So 4 divided by 3 is 1 1/3. So I kind of regret my choice now. It would have been easier to just keep it the original scale. So 1 1/3 works the same either way. All right. So 9, 10, and 11 is the same thing, but this time they don't give you the graph. They make it easier for you and they give you the points. Find K. So pause the video. Find K, the scale factor. All right, so I'm going to whip through these. You really only have to pick one point or the other. So either the y value or the x value. Doesn't matter what. Actually, my arrow will be going this way because it says R is the image of A after the dilation, which makes it easier. So the arrow is pointing at 12. 12 divided by 4 is 3. If I had done 3 and 9 instead, I also would have gotten 3. All right, 10, I'll go from 9 to 6. So that means I want to do 6 divided by 9. That reduces to 2/3. So that one is going to be a reduction. And 11, I'll go from 3 to 15, and they're both negative. So negative 15 divided by negative 3 is 5. That's an enlargement. So remember, it's just whatever the arrow points to divided by the other one. Okay, so 12 through 14, they give you K, and they give you 2 points from the original figure, and they want you to find what the new points will be after the enlargement or reduction. Pause the video, see if you can figure out how to do that. Unpause when you're ready to go over it. Okay, so this would be going back to the original rule where you multiply the x and the y coordinates by whatever the scale factor is. So in a problem like this, it's very, very simple. There's not much to it. We have 1 and 1 for A. B is 3, a little more room, 3 and 1. All I have to do is multiply everything by 2 because that's a scale factor. So 1 times 2, 1 times 2, 3 times 2, 1 times 2. So A prime is going to be at 2, 2. B prime is going to be at 6, 2. That's all there is to it. If you need to redo 13 and 14, you can go ahead and do that. Pause the video. If not, I'll keep going over them. So to multiply something by 3/4, you divide it by 4, then multiply by 3. So A prime is going to end up being, so 4 divided by 4 is 1, times 3 is 3, and they're both 4s, so those are the same. B prime, 8 divided by 4 is 2, times 3 is 6. 12 divided by 4 is 3, times 3 is 9. All right. And the last one A prime looks like it's going to be easy because it's zeros, so those will stay zeros. Multiplying 0 by anything keeps it at 0. And then -3 times 5 is -15. 2 times 5 is 10. The reason that it stays the same when it's at the origin is because the origin is the center of the dilation, unless otherwise noted. So kind of imagine like an explosion happening at the origin. That's why the center of it stays the same. If the explosion would happen somewhere else, it might move it from the origin. But if the origin is the center of the explosion, kind of everything expands around it. That's why the origin stays the same. A page like this is really similar. What my strategy would be to start is to list out what points A, B, and C are at. So I would say like A is at 1, 1, B is at 2, -1, C is at -2, 0. And then they give you the scale factor. So what we just did on the previous page, now multiply everything by 2 and draw the new dilation. So you have to actually list out the points. That's part of your answer. Say what A prime, B prime, and C prime are. That's half your answer. The other half of your answer is actually graphing it and plotting it. All right, make sure you guys finish up the assignment. Thank you guys so much for watching.